Okay, guys, we made it. We're here. We're still doing 5.3. Okay. As we go through these lessons, I will go back and do some review questions. Okay. So your goal is to get 5.3 finished. We will go back and review 5.1 and 5.2, and I will adjust due dates as needed. Okay, so we're going to cover something called quartic form today. All right? Now, when I did this for first period yesterday, nothing worked, so I had to take a picture of a student's notes so I could repeat it for you. So that's what I'm doing with my phone. So we are going to look at quadratic form. Now, we have our factoring flowchart. Red for GCF, green for patterns, and then we've got trinomials and grouping. We did patterns. We added 2 patterns last class, okay? And then we did grouping. Okay, so we added a little bit. Today, we're just going back to the trinomials. So this flowchart, it's still the same thing. We're just adding a few skills. So we have the quartic form, and that's going to be trinomials, okay? It has to be a trinomial that can be written as a quadratic. Can be written as a quadratic. Because the quadratic has the multiply-add numbers. So I'm going to write down a couple of these quartic forms. Ax squared plus bx plus c. Okay, so obviously that is the quadratic. That's the basic. We're going to write down a couple others that fit this format. So I'm going to up the degree. Ax to the 4th plus x squared hold on, no, I was trying to say x squared. I just left off my x. Plus c. Okay, I'm going to write one more. Ax to the 6th plus bx cubed plus c. So we're going to look at them and we're going to figure out why these are the quadratic form. Okay? So the first thing I notice is that x squared is x times x. Notice that the middle term is just one of those things. Okay? X to the 4th is x squared times x squared. Notice how the middle term is just one of those things. Okay? X to the 6th is x cubed times x cubed, and the middle term is just one of them. So it helps you recognize that it is the quartic form, because if that works, it's multiply-add numbers. We're like, yes, I'm good. I can do multiply-add numbers. Okay, so what we're going to look at here is ax to the n. What can you say about n? What kind of n values will work for quartic form? Not quite. Has to be even. Right? 2, 4, 6. It has to be even. Like a quadratic. Okay? So if I look at the bx to the exponent, what can I say about this exponent? How do I figure out what it is? It's half of it. It's n over 2. That's why n has to be even, because that middle term has to be half of it. Okay, so we've got this quartic form, and if I can figure out that it's a quartic form, then I'm just going to use multiply add numbers. So we're going to do an example. Okay, here we go. Example. X to the 4th minus x squared minus 6. Okay, so I am going to use two colors. All right, and I'm going to do this thing called U substitution. Okay, it's not necessary, but U substitution is a skill that shows up in multiple parts of math classes. So I want to show you how it works. All right, so I'm going to start here, and I'm going to say U equals x squared. All right, it's the middle term. And then I'm going to square it. Okay, so if I square the top row, I end up with U squared equals x to the 4th. And I'm going to substitute. So I end up with U squared minus U minus 6. Oh, U is a placeholder. It's a placeholder variable. You could use any letter you want. Y, W, Z. Well, because you're using X. So you want to pick a different letter. It's called U substitution. Like when you Google it, if you Google U substitution, something like this might show up. Okay? So factor your quadratic, right? It's a quadratic. Factor it. Can I multiply? I'll just do it over here. Multiply to negative 6 and add. Yes, I can. So then I'm going to write U minus 3, U plus 2. Right? I like the colors because I would like to write my answer in blue. In blue has X's, so write it with X's. Oh, if you notice that it's that quartic form, you do not have to show me the red, okay? You can certainly go straight to here. Now think about that foiling. Did the foiling actually work? First, outer, inner, last. Yeah, it actually does work, okay? The red step is optional. It's not necessary to actually complete the problem. And lunchtime. Okay, I am just going to write the example down, and then we'll just do it after lunch. Wah, wah. Okay, so we'll go 3x to the 4th minus x squared minus 2. Okay, there you go. And so I think what I'm going to do in order to factor is just sort of figure it out. So I'm going to multiply to negative 6 and add to negative 1. Okay, so that means that it will factor. Okay, so okay, so I'm going to do a little grouping here. All right, so the GCF is, okay, so we end up with U minus 1 and 3U plus 2. Now, if you can go straight from here to here, great, do it. Okay, right? Back to blue. So I'm going to take this, right, back to blue because I want x's. I'm actually going to write this one first. Okay. Don't box it yet. That was just one loop on my factoring. I ended up with a trinomial, and I did the trinomial factoring. Now I have to go back through my list. I want to look at 3x squared plus 2. I see an x squared. So, like, maybe it has to be green because it's only a pair of terms. X squared is a perfect square, but 3 is not, and 2 is not. So there's no pattern that works here. So now I'm going to go to the other factor. I'm going to go through my loop again. Okay, so I see x squared. So I'm thinking, could this be a pattern of squares? 1 is a perfect square. And so this piece right here, you are going to keep factoring it because it's a difference of squares. So 3x squared plus 2, right? That just stays there because nothing happens. And this one turns into a difference of squares. Okay. Oh yeah, here we go. Can I flip my page? Yeah? Anyone still? Yep. Just 4. Yeah. All right, here we go. Okay, hold on, I'm just thinking real quick. Okay, almost there, almost there. Okay, 4x to the 6th power minus 5x cubed plus 1. All right. Is it a quartic form or is it in the quadratic form? So I'm going to start with the middle piece, and I'm going to write u equals x cubed and u squared equals x to the 6th. Right? You have to make sure it's the quadratic form so that the multiply add numbers actually work. Okay, so I'm going to do my substitution. U squared minus 5u plus 1. Okay, can I actually factor that quadratic? Oh, well, let's check. Can you multiply to 4 and add to negative 5? Okay, yes, that means that it does factor. I'm going to show the grouping because from what I've seen, a lot of people forgot this part. But when you've got that number in front, you have to make sure that your FOIL actually works. So 4u squared minus 4u minus 1u plus 1. Okay. Okay. GCF is a 4u, u minus 1. GCF is the negative. Watch those signs. Okay. Common factor comes out. All right. Now, if you know how to do your guess and check, obviously you can skip straight to the factors. Okay, I'm showing you the grouping because at least half the people I've seen needed a little reminder on what to do with that number in front. Okay, back to blue because my answer is supposed to have X's in it. Right, don't box it yet. That was just one iteration. You gotta go again. Okay, so I'm gonna look at my first factor. It's a pair of terms. It's green, right? Green is for pairs over there. I see x cubed, so I'm thinking, could this be my cube pattern? Yes, because these are both perfect cubes. So I'm going to take this factor, and I'm going to do my cube formula, the SOPs. SOPs. Square, opposite product, square. Right, and then I'm going to check the other factor, and I see the 3 exponents. So I'm thinking, could this be cubes? Well, 4 is not a perfect cube. 1 is a perfect cube. But 4 isn't. That means that the pattern doesn't work because they're not all perfect cubes. And so this is just going to carry through. Oh, opposite product. Opposite the sign, product of x times 1. So this is x times x times 1, 1 times 1, and this was a minus, so we said opposite. Yep. Okay. Last one. This one is going to be big. Not more space, just big numbers. 13. Y to the 12th. You can do it. You can do it. I know you can. Minus 22 y to the 6th. D to the 4th plus 9d to the 8th. Like, lots of letters. Okay, so my first thought is this the quadratic form, right? First, it is a trinomial. So I'm going to look at the variables. So I have y to the 12th and y to the 6th. And I do see that half relationship. So, yes. Okay. Now, I'm going to look at the d's. Now, notice that this one, okay, so d to the 8th, and the middle term is half. So, I think that this is a quadratic form because those exponents have the half relationship. And I'm not going to do the u sub this time. I'm just going to try some multiply add numbers. Okay, can I multiply? So 13 times 9. Okay, so let's try. 13 times 9. Okay, is 117. And can I add to 22? Well, I don't really know what numbers multiply to 117. But I do know that 9 and 13 are one of them. If I just use them. These things actually get to 22. Okay, so I have two numbers that will work. So instead of doing the u sub, I'm just going to do grouping. Right, I told you the red part wasn't like absolutely necessary. It was just something that I was showing you. So I'm going to start by splitting this up. Oop, oop, forgot the D. Okay. Notice how the middle term keeps the same letters. 13 minus 9, y6, d4 plus 9, d8. And then you do grouping. Yes?
What's the exponent on the 15 line? Second one.
This is a 6. Is that good? All right. Let's group it and see what happens. 13y6 okay, right, just GCF. Oh, okay. Okay, and I'll pause there before we check our second and third iterations for our factoring. Okay. I'll let one of you brave people answer. Okay, we're going to do our next iteration. Notice that this is only 2 terms here, so we are only looking at the green stuff or the patterns. Difference of squares, difference of cubes, sum of cubes. Do any of those patterns work for this one? Yeah? Question? Answer? No, just stretching? Okay, that's right. Does anyone see a pattern that might work here? Olaf, you look like you're thinking. Okay, tell me what you're thinking, even if you don't have an answer.
I was going to say difference of squares, but I don't know.
Okay, so why did you want to start with difference of squares? What did you see that made you think that?
Well, the subtraction sign, and they're both like even.
Okay, the subtraction sign, so difference of squares or difference of cubes, good. And are they perfect squares? So let's try to square root and check. Okay, square root is multiply twice. So y cubed times y cubed. So it does work. So it's basically 2 groups, 6 into 2 groups. So that is y cubed. Okay, square root of this one is, right, it's half. Okay, so yes, difference of squares is it. So y cubed, so right now I am just looking at this part. And I'm going to do that difference of squares pattern. Minus d squared cubed plus d squared. And in order to not waste my writing, I'm just going to look at this cubed and squared. They're not perfect. This is a perfect cube, but this is a perfect square. So I can't use the pattern because I only have one of each. So nope. Cube and square, so the pattern doesn't work. All right. Whoop, back up. Y to the 6th and d to the 4th. Those are perfect squares. 9's a perfect square, but 13's not. So you can't use it. You can only use the pattern if all the pieces match. Whew. record. Okay, fundamental theorem of algebra tells me that the degree, so that's the highest power, okay? The degree is the highest power, okay, equals the number of solutions, okay, equals the number of solutions. Now, when I say solutions, I mean the real and the imaginary, okay? And when I say real, I mean to include multiplicities. So a quick example here, okay? Now I'm going to say turn points. Remember, the curvier the graph gets, the higher the degree, okay? So turn points plus 1. So we have two things that tell us about the degree. One of them, right? These are visuals. Okay? These are visuals. Now we're actually solving algebraically here as well. Okay? So we're sort of going to be putting all of these things together. All right, so an example. All right, so we're going to go like this. The specifics are not important. Just it crosses the x-axis once, and it's got two turn points. All right, and I'm just going to write the numbers 1 through 7. All right, so how many turning points do I see? I see 2 turning points. So with the 2 turning points, the degree could be 3, right? Because it has to go up. So what I'm going to do is I'm just going to cross off the possibilities here. That means that the degree cannot be 1 and it cannot be 2.
Wait, doesn't it have to be
3 or more. Notice I've got all these numbers that are not crossed off yet. Now, we're always trying to pick the minimum possibility, so it's whatever the smallest number left. Okay, so next, I'm going to look at the real solutions, the things that I can see. No, there's 2 turning points. The degree is always 1 more than the curve. Okay, so I see 1 x-intercept, which is repeated once. See how it goes straight through? So that means I have 1 solution. Well, it's not degree 1, guys, because it's too curvy. So what's the smallest number that's not been crossed off? 3. Can somebody give me, yes? Why would I put both up here? Oh, you can't tell imaginary by looking at a graph because they don't appear on the graph. So it's going to be a little bit of a process of elimination to figure out how many would be imaginary. Okay, okay. So I would like somebody to tell me which numbers of 4, 5, 6, and 7 can I cross off? Which numbers can I cross off? Which degrees aren't going to work? Yeah? Yes? It can't be even. Yes, awesome. Colleen and Anna, thank you. Ooh, okay, so our response here, shouldn't you also cross out the even numbers because the endpoints are opposite? The end behavior is opposite, and so that means the degree has to be odd. All right, so if my degree is 3, okay, if the degree is 3, and I can only see one real solution, what's left over for the imaginaries? Yes? 2. Yeah, 2 of them. Because the degree has to equal the number of solutions. So 1 plus 2 is 3. Okay. We'll do another little quick one here. Okay. This is like the last lesson we did right before break. Yes, Lee. So the minimum possible degree would be 3. If I decided to say that the degree was 5, there would still only be 1 real, but maybe there would be 4 imaginary. Imaginary you can't tell on a graph. Okay? So we always pick the smallest possibility so that we're all choosing the minimum, at least this has to happen. But if I actually had an equation, I would know for sure. Right? Because I don't have the equation right now. Okay, so let's draw another one. Let's do... Okay. So I'm just going to write down, and we're just trying to guess what the degree should be. That's all we're trying to do. What should the degree be based on the picture? Yes. It should be odd. Great. So I'm just going to just cross off. Okay. You can cross these things off in any order that you find the information. Okay. How many turning points? That's not a turning point, guys. It does not actually change directions. Kind of squiggles a little, but it's not actually changing directions. So 2 turning points means the degree should be 3 because it goes up 1. So I'm going to just cross out everything below. Okay. How many real? Well, I got to bounce. And my multiplicities tell me that the bounce counts as 2 solutions. This one counts as 1. So there are actually 3 real solutions. Well, I already crossed off the stuff below it, so that leaves me with 3. That's what it leaves me with. So if my degree is 3 based on the turning points and the x-intercepts that I see, then the real is 3 and the imaginary has nothing left. Now that is just based on the graph. Oh, perfect. Okay. Ooh, this is good. Okay. I need. All right, I'm gonna make it fit. Example. I guess this is 3. solve for x. So I'm going to give you one example on the solving, okay? And I'm going to tie it to some of this vocab we were using. So I'm going to say 3x to the fourth minus 3x equals 0. Okay, what's the degree? 4. How many answers should there be? 4. So if you don't have 4 answers, guys, you're missing something. Okay, how do you solve? By factoring. So factor it, right? Factor it. I see a GCF of 3x. I'm super amazing at factoring now. And I'm going to do another little iteration on my factoring skills. And I see, what do I see? Cubes. I see cubes. Okay, so I have to do the cube factoring. You've got to factor completely before you try solving, okay? You have to. Whew. All right. Okay, so now I'm going to just switch colors because this is like phase 2. I'm actually just going to set each factor to 0 because that's how you solve by factoring, is once you factor, you take each factor to 0. Okay. So the first 2 are pretty reasonable. Got 0 and 1. The next one seems to be a little meh because it doesn't factor. So yeah, it's either complete the square or quadratic formula. I'm going to just use the quadratic formula because those numbers look really small and I think it should be reasonable to simplify. So opposite b plus or minus b squared minus 4ac all over 2a okay. All right, guys, so let's look. The degree is 4. I have 2 real answers and 2 imaginary, because 2 plus 2 is 4. So if you were to look at the graph, right, if you were to put this graph in Desmos, you would get the same type of information based on the x-intercepts that you would see. So there's 2 imaginary, right? There's the imaginaries because I got the I. Here's the real because there isn't an I.